Hi everyone, I'm Virat, working as a Boomi developer in TJ's Office Solutions. Today, I'm going to discuss about health check process. The contents that I'm going to cover is what is tightly coupled integration and disadvantages of tightly coupled integration, what is event-driven architecture and why event-driven architecture, and health check demonstration. So, what is tightly coupled integration? Tightly coupled integration is an integration pattern in which two applications are highly dependent on each other. In this particular example, we're fetching the account records from the Salesforce and sending into the database system. In case of any failure process execution, then the data is lost. So it is not highly reliable. And in case if you want to get the accounts records from the Salesforce, and if you want to send to any of the target systems such as SAP, in this scenario, we need to create new integration process with the same logic. So this doesn't offer us any scalable approach. So the business moving towards the event-driven architecture. What is event-driven architecture? Event-driven architecture is an integration pattern in which two applications communicate with each other asynchronously by publishing the events and subscribing the events via the event broker. Here we are introducing the event broker, Boom event streams in this case, where the Salesforce publishes the events to the Boom event streams, and there is a consumer process which consumes the messages from the event streams. So why event-driven architecture? So it provides us the loosely coupled nature. It decouples the two applications and there will be less dependency between the two applications. Asynchronous communication. The publishers publish the messages to the event stream or the event broker and doesn't wait for any of the response. Reliability. In case of any connection level failures or data level failures, we can retrieve the data. There are mechanisms to retrieve the data. This data known as the dead letters. And scalable approach. We can onboard new applications or target systems without disturbing the current flow. Now, the design of the event-driven architecture. So there will be a publisher process who are going to publish or send the messages to the event broker, and the event broker are going to manage those messages in the cloud, specifically in the Boom event streams. And we need to design the consumer process which consumes the messages from the event broker. So here in this particular example, we are consuming the messages and sending it to the database. Consider in case of any connection level failures with the database, then the process execution fails. But the business doesn't require the failure execution, especially for the connection level failures. In this scenario, the businesses are moving towards health check process. What is health check? So health check process is a process that we can design. So the main purpose of health check process is it checks the status or availability of the target system. If target system is up, it resumes the listeners or consumers. If target system is down, it pauses the listeners or consumers. So the requirement here is we need to operate on the event stream listeners, which has database as the target system. Now, the event stream listeners, which has database as the target system, can be identified using the process name. The process name contains DB in the name of the process. Let me take you to the Boomi platform and show you how the event health check process look like. Yeah. So this is the health check process. So let me take you to the listeners that are deployed. To do that, we need to go to the manage. We need to set the runtime management. We need to select our runtime. And we need to select listeners. So when we select listeners, we'll be getting all the listeners. And here we have the event stream listeners. And the listeners has the database as their target system and SFDC as their target system. And here currently we are operating on the database as the target system. And the event stream listeners, which has database as the target system, can be identified using the process name. It contains DB in the name of the process. Currently we are operating on these event stream listeners. So this is the health check process. Start shape is configured with no data to support the scheduled integrations. And try catch. In try catch, the failure trigger is all errors. So in Boomi, we have two types of errors, that is document level errors and connection level errors. In order to handle the connection level errors, we are making it as all errors. And to check the status of the database, we need to perform operation on the database. So to do that, we need to configure the connection component and operation component. Now, connection component specifies how to establish connection with the database. We need to provide the necessary details such as database URL, driver type, username, password, host, port, and database name. These are the required details in order to establish connection with the database. Once we have established connection with the database, we need to specify what is the operation that we are performing on the database. To do that, we need to configure the database operation component, and we need to configure the profile component as well. And here we need to specify the operation that we are performing. Here we are performing select operation, so which retrieves this particular select query retrieves number of records available in the database table. So once it fetches, the connection is successful. So if the connection is successful, we are making use of set property shape and assigning a value of up to the dynamic process property. This dynamic process property simply I use it to identify whether the target system is up or down. In case of connection level failure, it comes to the catch path, and in the set properties, we are assigning down value as down to the dynamic process property. And once after this, we need to fetch all the listeners deployed in an environment. Now here we are communicating with the Boomi platform. To communicate with the Boomi platform, we have Boomi Atomsphere API. So this Boomi Atomsphere API use it to communicate with the Boomi platform, and we need to configure connection component and operation component. In the connection component, so in the WSDL URL, account ID is the placeholder that we can provide, which we can get from the URL above. And authentication type is password. We need to provide the Boomi credentials for the username and password. And action is query. Now, to fetch all the listeners deployed in an environment, we are making use of listener status object, and we need to pass the runtime ID. We can get the runtime ID. So we need to direct to the manage runtime management. We need to select our runtime. After selecting runtime, we need to select the runtime information, and we can copy the runtime ID from here. So here we are passing runtime ID as a parameter. So this fetches all the listeners which are deployed in this runtime. So once we are fetching all the listeners, we need to filter the event stream listeners. To do that, we are checking whether the connector type, which this connector type we are getting as a response from the listener status object, and we are checking this connector type is equal to standard value. So the event stream connector has this standard value. We are checking the value. So it filters all the event stream listeners. And in the true path, once we are getting all the event stream listeners, we need to check whether it contains database or not. So to do that, we need to check whether the process name contains DB or not. For that, we are making use of Boomi Atomsphere API object again. Here we need to make use of process object. We need to pass the process ID in order to get the process name. Now in the parameters, we need to pass the process ID or component ID, which we are getting as a response from the listener status object, and we need to give the process name. So this particular value checks whether the process name contains DB or not. If it contains, it filters out. So here we are getting the event stream business which contains the database as the target system. Once we do that, here we are checking the status of the target system by using the dynamic process property. If it is up, it comes to the true path. If it is up, we need to resume the listeners. To change the status of the listeners, we have change listener status object. Now we need to pass the parameters for the listener status. The parameters that we need to pass are container ID, or also known as the runtime ID, to pass the runtime ID, and we need to pass the listener ID or process ID or component ID, which we are getting as a response from the listener status object or process object, and we need to pass the value as resume to the action. So this specifies to resume the listeners, and in case the database is down, we need to pause the listener. For that, we are providing the values passed to the action. So before executing the LCHEC process, let me show you the status of the listeners. To that, we need to select our runtime and select listeners. Yeah. So all the event stream listeners, which has database as the target system, is in resume state. So let me pause the database service. That is database. We are stopping. And let me execute the LCHEC process. Now we are making use of local runtime. The database is installed in my local machine. To establish connection with the database, we need to make use of local runtime. No, it is checking the database. So since the database connection is not established perfectly, so the database connection has failed. So it is coming to the cache path. So since the database is down, it need to pause all the event stream listeners, which has database as the target system. So it came to false path. And let me go to the listeners and let me refresh it. So here, since the database target system is down, it paused all the event stream listeners, which has database as the target system. Now, let me restart the database service and execute the LCHEC process. So since it tries to establish connection with the database system, since it established successfully, it will resume all the listeners which has database as the target system. So let me go to the listeners and refresh it. It is resuming all the event stream listeners which has database as the target system. So this LCHEC process can be a scheduled integration process which checks at regular intervals, it checks the status of the target system. If target system is up, it resumes the listeners. If target system is down, it pauses the listeners. So using this LCHEC process, we can reduce the failure process execution for the connection failures. That's all from my side.